Alright, I wanted to show you guys an example of what I'm looking for in question 2 of assignment 9. So here's a similar example. We want to show that these four vectors are linearly dependent. So we have vector 1, vector 2, vector 3, and vector 4. Now these four vectors are linearly dependent if there are A, B, C, and D real numbers, which are not all 0, such that this linear combination is equal to the 0 vector. Now this is a slight extension of what we looked at in class. In class we only talked about 3 vectors, and then coefficients A, B, and C. But in general, whatever number of vectors you have, they are linearly dependent if some non-zero linear combination of them is equal to the 0 vector. So however many vectors you have, if you can find a non-zero linear combination of them that is the 0 vector, then they are linearly dependent. So this equation is going to give us actually a system of equations. So this one equation is going to give us the system where we have, let's see, A plus B plus C plus D is equal to 0 from the first entry in the 4 vectors. Equal to the first entry in the 0 vector, and then do the same thing for the second and third entries, and that will give us, let's see, 0a plus 2b plus c plus d is also equal to 0, and for the third entries that will give us a plus 0b plus c plus 0d is equal to 0. So this gives us a system of equations to solve. Now we can write this as, matrix equation. Alright, so AX is equal to B. Right, in this case B is equal to the 0 vector. So our coefficient matrix would be 1, 1, 1, 1 for the first row, 0, 2, 1, 1 for the second row, and 1, 0, 1, 0 for the third row. So the coefficient matrix times the solution vector A, B, C, D is equal to the 0 vector. 0, 0, 0. Okay, so this is the matrix equation which we're interested in solving, which we can solve by reducing the coefficient matrix to row echelon form. So if we take the coefficient matrix 1, 1, 1, 1, 0, 2, 1, 1, 1, 0, 1, 0, and we find the row echelon form, we will find that that is, top row stays the same, 1, 1, 1, 1. The second row is 0, negative 1, 0, negative 1, and the third row is 0, 0, 1, negative 1. Okay. Now, looking at this is going to tell us that C minus D is equal to 0, and so on, which gives us that D is a free variable. So let's let D be equal to T, and let's say we can actually let that be equal to negative 1. Okay, and that will give us that C is also equal to negative 1, B is equal to 1, and A is equal to 1. So finding these, not all 0, in fact none of them are 0, this tells us that V1 plus V2 minus V3 minus V4 is equal to 0. If you wanted to write that out as the actual vectors, you could write 1, 0, 1 plus 1, 2, 0 plus 1, 1, 1. I'm sorry, we're minusing that third vector, and subtract the fourth vector, 1, 1, 0. This is equal to the 0 vector. So the vectors are linearly dependent. If we wanted to write one of the vectors as a linear combination of the others, all we would have to do is get one of the vectors on this side. So for example, I could add the fourth vector to each side, and I would have 1, 0, 1 plus 1, 2, 0 minus 1, 1, 1 is equal to 1, 1, 0. And now I have written one of them as a linear combination of the other three, as you are asked to do in question 2 of assignment 9. Please send me an email if you still have any questions. I'd love to help you guys out.